So we have Casper and Emil here from the Concordium Foundation. Concordium, as you know, is a science-backed layer 1 blockchain, which is enabling the largest migration in the history of the internet in terms of the status quo today, which is Web 2 to Web 3. And they're based on the Rust language framework. And one of the core driving thoughts behind running this hackathon was to explore the depth and the strength of the skills that the Indian subcontinent has to offer in terms of Rust coding. And we decided to work with our top tech schools, including the IITs. We tied up with Google developer communities, some of the most active DAOs, in order to reach the best developer populace that we could imagine. And Casper and Emil here lead everything to do with smart contracts and integrations on the Concordium platform. And they're here to talk about or give you a more technical introduction to Concordium and the kind of coding you can look forward to. So thank you for joining us, Casper. Thank you for being here, Emil. And thank you, Marco, for making this happen. Over to you, Casper.
Yeah, thanks.
And just a heads up, we are also going to take questions from people in the chat section. What we agreed is, in case you have a technical question midway, do put the question on chat. Alternatively, you have an option to raise your hand. We will take those questions at the last 10 minutes of the session.
Yeah, just write in the chat, and then like Emil is ready for answering. And if it's a longer question or a longer answer, I guess, then we'll take it in the end. I hope to have like around 10 minutes.
Also, a brief request, and this is the last bit of my interjections here. If I could request as many people as possible, if you're comfortable, please do switch on your video. It's not like a house rule. In fact, once the session begins, Casper, we will go ahead and turn off video sharing so that the screen share happens more efficiently. But I would want to take a small memoir of this moment where everybody's here for the first time. So if you can switch on your videos, that would mean the world. Hey, Arpit. Hi, I can see your name is DB Food Diaries. Thank you for being here. I think we'll move on to the session, Casper.
Okay, great.
Thank you.
Okay, let me just share my screen. Okay, can everyone see this infinite thing I'm sharing?
The loop is visible.
Yes, cool. Okay. Okay, great. So I'm Casper. Yeah, I'm working at Concordium as an engineer in the smart contract team. Today what we're going to cover is something about like an introduction to Concordium, and then the Rust programming language, and then we'll move on to smart contracts, where we'll write our own smart contract in Rust for Concordium. Yeah, so I'll go into a bit about why Concordium and some details about the Rust programming language. I do expect you can program, but I will cover some of the more novel things in Rust, and then we'll build a voting themed smart contract. We'll test this and deploy it on the testnet, and then we'll look at some additional resources, and we have questions in the end. So Concordium is the layer 1 science-backed blockchain creating a safer digital world. And that's like we have a number of features, but two of the most important ones for this session today is that we are the only blockchain where you use identification that's built into the protocol. And I'll show you in a bit what that means. And you can also prove statements about yourself and your ID using something that's called zero knowledge proofs. So that could, for example, be that you can prove that you are from, say, the EU or from Asia without revealing which country you're from. And we're going to use that in the next session, like tomorrow. So the way that you create an account on Concordium is different from other blockchains, for example, Ethereum. On Ethereum, you just create a public and private key pair, and then you're ready to go. But here, what you do is that you use one of our wallets, and then you use your passport or ID document, and then you take a photo of it and set it into something that's called an identity provider. And then you also take a screen, like a selfie. In the EU, you can also use a similar option, which where you just like use the public national ID, where there's an app, so you can just like swipe. That's the easy solution now. But at least you can do this as well with your passport, and then once they verify that you are who you say you are, they will create an ID object on the chain for you. And then from this ID object, you can create one or multiple accounts. And this ID object is private, like no one else can see it. But it does contain your name and your name and birthday and these sort of things. And then you can use this information later as zero knowledge proofs. So we're going to cover that tomorrow. But no one else can see this. That's the important part. And what you can then do is that you can really trust the users on Concordia blockchain. And if there's any crime committed, then there's actually a way, mechanism for finding out who an account belongs to. So there are these entities called anonymity revokers, which are some lawyers that are spread around the world. And then if there's a court order saying someone has stolen some money or something like that, then the anonymity revokers, they can go together with the identity providers, and then they can like cryptographically unlock the identity behind an account, and then find out who the person is, and then the person can be prosecuted. So that this mechanism makes it so that you can really trust the Concordium blockchain and use it for businesses can also use it, and governments even. Right. So now we'll move on to the Rust programming language. We'll be joined by Ferris, the official mascot of Rust. And as I said, we'll focus on the things that make Rust different and more unique. And I expect that you already know how to program. So what is Rust? It's a systems programming language. That means that you can build like an OS in it, similar to like operating system, similar to like you can do in C and C++. It's one of the most popular, or it is the most popular language for 7 years in a row. It has a very strong type system, so everything has a type, and the compiler will catch a lot of your mistakes. And then it has these nice high-level abstractions, so it's very nice to use and nice to write code in. But it comes at a zero runtime cost. So at runtime, it's as fast or nearly as fast as C and C++, despite having much nicer user experience or developer experience. And then it has this ownership model for memory handling. That means there's no garbage collection and there's no manual freeing of data. And this, besides handling the memory for you, the way that the ownership model works, it also gives you some very strong guarantees against common bugs, for example, concurrency bugs. So in case you don't recall all the details about memory, I'll just quickly go over it. So there are basically 3 ways, or there are 2 common ways, at least, for handling memory. Like in C and C++, you manually allocate memory when you want to have like a string or vector or something. You say malloc or alloc or something, allocate. I want this much space. And then afterwards, you have to free it yourself. And this is error prone, and it's difficult to do right. And then there's like garbage collection, which Python's JavaScript, C#, Java, whatever, uses. And in here, there's like a garbage collector program that runs in the background and cleans up the memory of your program. And Rust is novel in that it has this ownership model where there's no manual freeing of data and there's no garbage collection. So that sounds a little bit magic, but this ownership model actually is it's not too complicated to understand the basics, but it does take a while to get used to. And there are these 3 rules that underline it. there are so each value has an owner, and there can only be one owner at a time. And when the owner goes out of scope, the value is dropped, i.e. freed. So here we have a small Rust program. You have curly brackets to delimit the scope. And here we say that we have a string hello, and we assign it to the variable s. And then here we can do things with s. And then once the scope finishes, so the owner s goes out of scope, then the string here hello is freed. So in order to understand a bit, that was like the basics. To understand it a little bit better, it makes sense to recall or remind ourselves how the memory of a program is organized. So it's split into the stack and the heap, and that's the case for any program. And you have the stack that is for data of known and fixed sizes, such as numbers and bools and pointers. And then you can put them on top of each other like a stack of plates, and it's called like last in, first out. So it's very easy to take the top plate out, but it's very cumbersome to take like the middle plate. But it's also very easy to put new things on top of the stack. And on the other hand, you have the heap, and that is for data of variable and changing sizes, for example, strings or lists or trees, these sort of things. And it's less organized, and you request the amount of data that you want in there, and then you get a pointer to it. So an example is that you go to a restaurant and you say a table for 8, and then the waiter will show you to the table and say, this is table number 17, this is now your table. So the 17, that's the pointer. And this pointer can be stored in the stack, actually, because it's a fixed size. And then when your the friend who is always late arrives, then you can just tell the person, oh, go to table number 17. And the person will go to the waiter and say 17, and then go to the table. So this is like following the pointer. And that is, of course, slower than just taking a stack of plates, because you have to follow the pointers. All right, with that in mind, we're ready to, to look at another example here. So here we have, let me just take time. Yes, okay. Here we have x, we set it to 5, and then we say y is equal to x, and then we try to print both of the values. Here we use string interpolation, so when you see these curly brackets, then it takes this variable and tries to print it. And what happens? It prints both of them. Okay, and here we have a different example, which is kind of similar. Here we take a string, hello, and we assign it to s1, and then we say, create a new variable s2 and then assign s1 to it, and then we try to print s1, like the first one here. And that, of course, works as well, except it doesn't. And that is, then it gives you a long message about a move occurs, and there's some value moved and borrowed after move, and these sort of things. The compiler is actually really helpful and explains exactly what happens, but it does in a nice way, but you need to learn the lingo about this ownership. So what happens here is, or the difference is that numbers, which you use over here, they have a known and fixed size, and they live on a stack, so like a stack of plates. So they implement the copy trait, which is a trait is like an interface. And so what is happening here is that you're actually copying the value of x into here and then assign it to y. So you have two copies of the same data. But Rust is built to be really efficient and to be very explicit when you do things that are expensive. So what happens over here is that because the string has a variable size and live on the heap, and we know the heap is expensive. Remember the restaurant, you go to follow the pointer, right? So it's very expensive to make like get a new table, right, at the restaurant. That takes a while. It's much more complicated than just adding another plate. So Rust tries to be smart and not not do the expensive operation. So instead, what is happening is that we are moving the ownership. So initially, the hello string is owned by S1, but then what happens here is that S2 takes ownership of hello, and then S1 goes out of scope. And but how do you then deal with these sort of situations if it is the case that you do want to print S1? Well, one way is to structure your program so you don't print S1. And that sounds like tongue-in-cheek, kind of like a joke, right? But actually, over time, you do learn how to structure your program so you don't run into these issues. And usually, I find you actually get a better structured program than you would otherwise. Another option is to use the clone trade. So remember how I said that Rust tries to be explicit about doing expensive operations? Well, this is what we're doing here. Here we're saying, get us a new table, like create a new string, hello, on the heap. And then here, we want another string on the heap that's called, that is also hello. But this is expensive, but you do it explicitly by this clone. And then you're allowed to print both of them, and that works due to this clone here. The third thing you can do is to use references. So while there's only one owner at a time, you can't borrow, like lend out the values and then get them back. So let's look at that. Here I'm using some functions to show it. So here we have a function, you write fn to define function, and then it's called takes ownership, and it has one parameter s of type string, and then whatever it does in here, it prints the string. And this is similar to what we saw before. This is where it takes ownership of the string. So when you call this function, then it says, okay, now s, the variable s here, is now the new owner of the string. We print it, and then once the function finishes, s goes out of scope, and the string is dropped, i.e. freed. We can also borrow immutably, meaning that we cannot mutate or change the value. And that we do with the ampersand here. So notice that there's an and sign here before. So when you call this function, we say that, okay, s now has borrowed this string, and it can use it for printing or various things without changing it. And then when the function finishes, s is still alive, and it's handed back to the owner, or maybe someone else who borrowed it. You can actually like borrow and then forward the borrow and forward the borrow, etc. And the last option you have is that you can have a mutable reference to the string. So here it says ampersand mute, and that means that you hand out like a reference to the thing where the one who now loans it can change the value. So here we are pushing a string saying that it was changed. And then once this function goes out of scope, s is still alive, but it's now changed. Okay. So that was like some things about the ownership model in Rust. And now, one thing I should mention is that you can have multiple immutable references to the same thing, but you can only have one mutable reference at a time, and you cannot have both immutable and mutable references at the same time. And that's because if you get like a immutable reference, then you expect the thing to be static, that it won't change. Okay. So now we covered some things about Rust and the ownership model, and then we'll cover the rest while I'm writing our smart contract. So let's move on to that. Yes. So first off, an introduction to smart contracts. A smart contract is like a small piece of code or program that you can put onto the Concordium blockchain, and then you get some new feature and some new behavior that you can now do with the smart contract that is not inherently built into the core protocol. On Concordium, the smart contracts are WASM modules, which are WebAssembly. If you work with JavaScript, you might know WebAssembly. It's like a type of assembly, but built for the web, which is has like some neat features that fits well for our use case. And you can compile to WASM with a lot of languages, but Rust has the best support for writing our smart contracts, like smart contracts for Concordia. So the way that it works is that you write a smart contract in Rust, and then you compile it to a WASM module. And then with this WASM module, you deploy it, where you put the code onto the blockchain. And then once you have that, that is sort of similar to like now you have like a class, you can think of it in object-oriented programming. Then after that, you can initialize multiple instances of this module by initializing it. And this can also take some parameters and stuff. We'll see that. And then once you have an instance of a smart contract, then you can update it any number of times according to its own logic. So it might say that only the owner can update this thing, or only if your contract starts, or if your address starts with whatever. That's up to the smart contract. Yes. So the thing we're going to build today actually is also a very realistic problem. So imagine that this is you like singing, you like competitions, and you hear that the new Eurovision Song Contest is coming along. So you think to yourself, great, I'm going to vote for my own country. Of course, right? But then you read the rules and you realize that, okay, you're actually not allowed to vote for your own country. And then you think to yourself, how is this actually enforced? And if you look it up, you see that one way to vote is to use your phone and call in, and then they check the country code. But of course, you can buy like I don't know, it's called like a burner phone or something from a different country, and then so you can circumvent it. Then you can just vote for your own country. You can also vote with an app, and maybe that uses your IP address or something. Maybe you can use an VPN, something to get around it. At least there are multiple ways to get around this restriction, right? So you can vote on your own country if you really want to, but that's not very cool, right? Because then large countries have a big advantage over small countries such as Denmark. And then you think to yourself, wasn't there something about Concordium and its identity layer? So recall these attributes that you saw. There's also country of residency and country of nationality. This comes from the identity object, which is stored on the chain, which is private. But you can actually use this to prove things about yourself. So you can prove to someone else, hey, I'm not from, say I want to vote on Germany, I can say, I'm not from Germany. And you don't reveal that, for example, I'm from Denmark. I don't reveal that I'm from Denmark. I just reveal that I'm not from Germany. And this can be checked and verified, and then you get to vote. So that's what we're going to do today. We're building a smart contract that can handle this. So when we initialize the smart contract, then we give in some voting options. We give an end time. We give in a description. That's the idea. So voting options, like which countries can you vote on for this. And then when you vote, you just put in a country code for the country you want to vote on. And then in the ideal scenario, what we're going to do is that we check the country code, the country of the voter off-chain, and then we have a backend that checks this zero knowledge proof and then returns a confirmation signature, which is then included here. But that is not, and then the smart contract checks the signature from the backend, and then it saves the vote. But these things are not covered in this tutorial, as that would take a bit longer. But we do have a full example of it that is in the example repository. So it's in the Concordium voting workshop on GitHub. So instead, what we're going to do is that we're still checking the country of the voter off-chain, but then it's only the front end that checks whether you're allowed to vote, and the smart contract just saves the vote. It doesn't. So the smart contract is not aware of this ID check or the check of the country. So that's a bit simpler, but then you can go and look for the advanced version. It's in the advanced folder. Right. So let's start by installing the prerequisites. What you're going to need is the Rust programming language, and you need Concordium client. I won't install all of these things now, but you can follow these instructions. And then Cargo Concordium, which is a tool for building the smart contracts, and then Cargo Generate, and then Visual Studio Code Extension is what we recommend. You can also, like I use Emacs normally, but you can use like any editor you want. But we have like an extension for smart contracts in here that which I will show, which has some nice features. We're doing time. Okay. Cool. Okay, so now I'll switch over to Visual Studio Code, and let's find the extension here. Concordium one here. We'll install it. Okay. And yeah, I recommend also the Rust analyzer. That's for the support for Rust. Okay, and then from here, we are going to, like, you can open this command palette, and then we want to initialize a smart contract project. Like that, we can see all the here, initialize smart contract project, and we can say here, let's put it in here. And then this dialog comes up, and then we have two options. You can have a sys2 NFT, which is like our standard for NFTs, like a template for writing that sort of contract, or the default. And since we're not writing a token or NFT today, we're just using the default one. And then the project name, voting, for the vision contract. And then we're good to go. So we created this voting in here. So let's just open that. Should open a folder. Let's see. Voting. Here we go. So what we got was this voting folder. You have a lib.rs file, which is a Rust file, and then you have this cargo.toml, which is similar to like package.json. And in here you have some package information. You have some features, which is like things where you can toggle on and off. For example, if you are building, if you have an application where you have something special for Windows, you can have like a feature. So you say like, if it's on Windows, then it can use Windows whatever things. And then you have dependencies. We're using Concordium CD, which is the Concordium standard library for writing smart contracts, and then some other things here. The most important section is like the package and then the dependencies. So then it creates a cargo.log file, which is like where it finds specific versions of all the crates, as it's called, which is packages, and writes them down so where they're all compatible. And then you get a target folder, which is where the resulting code will live on binaries. And it created this just now because it Rust analyzer ran and tried to compile this code. Okay, so here we have, this is the file where our contract will live, and it has a number of things already. We're going to use this as a scaffolding for building contracts. Let's just get full screen. Okay, so we are importing Concordium CD and everything from it with the star, and then also importing this debug thing. That's not too important. And then here we are defining a struct, which is like a record, or like a similar to like a class, I guess. It's like a group of data you can have together in one thing. And so let's start with doing that. So the things that we're going to need to that the contract is going to be aware of is at least a description, which is like a string, maybe it's saying like this is the best or the best Eurovision way of voting for Eurovision. And then you have some options, which is the different voting options, and that we can use like a vector, which is like a list of things with strings. Actually, let's not do strings. Let's help ourselves and then say voting option is a string. So this is like a type alias. It doesn't help us catch any bugs, but it just helps us like to know, oh, this is not just a string, but this is actually a voting option. That might be helpful. And we have an end time. And what else did we do? Then we have to keep track of all the votes, ballots. And so we'll use a map for that. In Rust, it's usually common to use this B-tree map. It's just a specific kind of map or a dictionary. And we'll go from account address to, we'll go to a voting index. And let's see, what should a voting index be? So we could say that an account address votes on a specific voting option, like this string here. So you could store like this account address points to Denmark, and this one points to Germany, and this one points to Italy. But that is actually like it uses more space than is needed. Actually, it just needs to point at an index in this vector. It needs to points at the second voting option or the first voting option. So let's do voting index is like a U32, and that's how you write numbers. In Rust, you have like 28 is like 1 byte of a unsigned number, which is like a number that doesn't have like plus or minus. And then you have the integer 8, which is like a signed version, which does have plus or minus. And then you have like U16, I16, etc. Okay, so here we're using U32. Okay, I think that's all the things for the state. What we're also doing is that we are deriving some things. So in Rust, you can use these attributes up here over things where you see like a hashtag and then some square brackets and then some things you write in here. And one of the things you can write and often derive. So here we say that, hey, can you like generate the code for us for serialization, for like converting this Rust structure into binary and then back from binary into the Rust structure, because we're going to need that. And then we also have this schema type, which is a Rust like a Concordium specific thing, and it helps us. What it allows us to do is to convert the Rust structure here into JSON, and also the opposite. So that's very convenient for like printing things, printing the state, for example, when debugging or or when you're using other tools. And then clone here, I think it is needed, but that just means that we allow this thing to be cloned in memory. So when you write here, you actually say that this thing implements the clone trait. Okay, and then let's move on to the init function. So the init function is like the constructor, and that's a function that like constructs an instance of a smart contract. So there's a lot of things to unpack here in this simple function. Like, remember that a simple function is just like function if, and then it takes like a parameter a, and then maybe returns, and then it says a equals b. This is a simple function. And in Rust, you can, like, if the last line don't have a semicolon, then it just returns that line. So writing a plus 1 semicolon is equivalent to writing a plus 1. This is the more idiomatic way of doing it in Rust. This is like a basic function. Now we're doing a more advanced version function. So what it does here is that we have this function called init. It takes two parameters, context and state builder. And when you see these underscores up front, then that means that you ignore the parameter. And that's because you don't need it right now, like the default here. And then what it says is that we get a reference to something which implements has init context, which is a trait. You see, it says trait there. And then also implements a mutable reference to a state builder. A state builder is for doing more advanced things with the state. We won't use that today, but you can read about that in our documentation and other examples. I actually liked it here. Okay. So what we're going to do is that, like, the result of an init function is like the state like the initial state of the contract. So what we're going to do is that we're going to take some input parameter for, like, from the user, so that you use for initializing it. So let's say struct init parameter, and then what we need, it's going to overlap a lot with the state, but that kind of makes sense, right? Because we want to specify all the things, and then an int time, which is a timestamp. Okay, and then parameters for smart contracts is always, they only take in binary parameters. So we need to implement this serialized. And then, since it's very cumbersome to write binary files that you use for initializing it, we want to derive schema type, so we can actually just write a JSON file, and then our tools will convert it to binary and then send it to the contract. Okay, that's cool. What we're going to do then is get the parameter here, and then the way you do that is to use a context, and then you call this method that's called parameter cursor, and then you can say get. And this get returns a result, and a result in Rust is an enum. I'll just call it my result, otherwise it will be confused. But what it is basically is like an enum, which is, you might know enums from other languages, but these are quite a bit more powerful because they cannot just be, like A and B, which is basically like this is a different version of 0, and this is a different version of 1. That's like in C, that's what enums are. But here you can actually have like arbitrary data along with it. So you can have like this, if it's an A, then it has like a string and a U32. If it's B, it has nothing. And if it's a C, then it also has like some named things, my foo, and that's a string, and these sort of things. So that you can have, so my result is an enum where it's either a generic enum, CE, so it has two different types that it's generic on. So it's either OK and a T, or it's an error and it's an E. So this is used for handling like error cases or anything that can go wrong. So of course you could send in like some wrong binary, and then you cannot pass this parameter. So this returns a, let's just help Rust here, and say that this should actually be an init parameter, and then it will complain because we say that this should be an init parameter, but actually get here returns a result. So what we have to do is that we can match on it, which is like a switch case. Then we can say, okay, if it's an OK, param, then we just return the parameter. And if it's okay, no, I don't want it. And then if it's an error, then we just return an error. So what we're going to do is we're going to return error, and then what kind of, and then this init result is actually of default. This init result is alias for reject, which just means like we could not create this this contract. Just looking at time. Okay, so yes. So this pattern is very common in Rust, and what you can actually do instead is to use this question mark operator, which does the same thing. So the question mark operator will go in and say, if it's possible to convert the error type that's returned here, which is like a parse error, to this reject, then in the error case, do that and return early, and in the good case, extract the thing from OK, like the T in here, and then return it to the parameter here. So that's what we're going to do. And then we don't need the match, but just remember that the question mark is similar to like a match, where you say like, if it's OK, then give back the good thing, and then if it's an error, then return early, right? Okay, and then we will create the state based on the parameter. So we'll say the description, that's the parameter description, and then the options, that's param options, and then the end time is the parameter end time, and then the last thing is the ballots. And then here it doesn't make sense to send in like some initial vote. We just create a new map or new dictionary here, and then we don't. That was the like we could either write return and a semicolon, but we can also do the more Rust way and then just return here. So here we're returning OK for the init, and yeah, and then here we are using an attribute where we are saying this is a Concordium attribute, where we're saying that this is actually a contract voting. Called voting, and we will say that it has this parameter, which is the init parameter. And what this part does is that it generates some code for dealing with the so we can use JSON parameters later for initializing it. Okay, so that was a lot. I hope that you could follow along. Let's get this out. Okay. The next thing we're going to do, now that we've created the init function, is to create a voting function. So I'm just going to steal this here and put it up. Let's leave it down here. So here we have a different kind of function, which is a receive function, which is like the methods on your contract, the things you can call on a contract instance. And let's call it vote, and the parameter, that should be a voting option, right, which is like a string, and then has an error type, and that's again used for the schemas or for the JSON thing. And then we say that it's mutable because we want to be able to mutate the state. Otherwise, it's not possible to mutate the state. And the reason why we want to mutate it is because we want to save the vote. So we're updating the contract and changing the state of there. Let's call it vote. And this is also generic, same as the init thing was. And it's generic upon the state. And that's because we have two, when you're writing unit tests, we have like a different kind of state implementation. So one state implementation uses the blockchain to store things, and another one, a test one, uses the like in-memory way. So that's why it's generic. Again, we have the context here, and we have a immutable reference to an implementation, something that implements has received context. And we have the host here, and we're actually going to use that. And here we have this looks a bit scary, but it has a mutable reference to something that implements has host, where has host is generic on state, and it uses this, like this is our state that we defined up here. And then the state API type, which is what I said before about having the blockchain state implementation, and then the testing version. So this returns a unit or an error. And unit is just like you can have like a tuple with one thing or with two things, and then you can have something with 0 things, and that's like the unit. And that's like it's roughly equal to returning void. It returns nothing. So that's what you do in Rust. So here we're just saying that this function returns nothing, or like in the success case, in OK, it returns nothing. Otherwise, it returns an error. Okay. So what we have to do next is, so first we're going to check that the it's not an account, only accounts can vote. It's so no contracts. Yeah, let's just do that. So let's say that an account, we want to get the account, and then what we're matching on context.sender. So who sent this, like who called this voting receive function. And we have two options. It's either an account here, and in that case we just we return this account to this variable, so it's assigned here, or we can do contract, or if it's a contract, then we don't really care about it, and we just say return an error and say contract voter here. So here we have this error type, which is our own enum. So we can say these are various things that can go wrong. So one of the things is that it's a contract voter, and we don't allow that. Okay, and then we will try to get the parameter again. And that should be a voting option. So we're doing exactly the same thing as before. Parameter cursor, get question mark. And if this doesn't work, like if get fails, then it returns a pass error. And up here we are using like we're telling it if, like we're defining how to convert from a pass error to this error, our error enum. And we're doing that by saying from pass error, and then it will use this variant here. So then it's possible to convert it, and you can use the question mark. Okay, and then what we're going to do next is say, what am I going to say? So we want the new vote to be the like the index in, I'm not saying this right. Yeah, the index in the number of voting options. So host state options dot, and we get an iterator to it, so we can like iterate through it. Then we say position, and then we want to get the then the index, and then so with position is like function. So we want to get the position where the option here is the same as the new vote. So we're looping through all the voting options and then finding the position of this thing. And this returns an option, and an option is again an enum. And just call my option here, where it's either it's some t or it's nothing. It's none. There's no error variant, but it's used for things where it's obvious why the error is there. And then so this returns an option, and we're not really interested in that. So we're doing a match here, and then we're saying if it's a sum x, then we're doing is index, then we're saying index as 2, because we're going to use 2. Oh. And then if it's none, then we're saying that return an error, where's the error invalid voting option. So we'll create a version here. Valid voting option. Okay, that's cool. And then, so now we have the voting index, and then we can say post the state mute. So we get a mutable reference to the state, and then we say the ballots, and then we say insert to it the account, and then the voting index. And then we say okay. Great. And then I'm moving a little bit fast for time restrictions. What we're going to do now is then create a view function, which is a function for extracting things from the data and showing it to the outside. It has no like strict way, but usually like it doesn't mutate anything in the state. It's just a function for getting information. So here, what we want to do is to say we have a struct, which is the view data. And again, we're deriving some things for it. Schema type. And then what we're going to do is description, string, and then int time, timestamp, and then we have the tally, which is again a B-tree map, but now we don't really care about which accounts. We just want to say the voting option, and then the number of votes, U32. And then what we're doing here, we tell you that should be view data. And what we're doing is saying state. Then we want to get the description, state description, the clone. Here we're cloning it. And then the end time, state.end time. We don't need to clone it because that's a cheap thing that lives on the stack, whereas the other thing is a string that lives on the heap. And then we're going to create the mute. So one thing I haven't covered is that when you write this, then it's actually an immutable variable, so you cannot change it or mutate it. And so Rust is trying to be safe by default, and it's more safe to be immutable than mutable. So when you want something that's mutable, then you have to write mute in front. So here we're doing a tally, which will be a B-tree map, a new one, and then we will go through for all the count and voting count and index in state dot ballots dot iterator. What we will do is we'll try to get the voting option to be, will it be? It'll be the okay. voting option, there will be the options, and then we'll index into that and get the index as view size, and then going over a few details here because I want to show you testing as well. And then we'll say the tally dot entry, the voting option. So this means that we want to get the position in the tree where there either is something already or where we should put in a new thing. And then with this entry, we can say that and modify, and then we can say the count, and then we can increase the count by 1. Or we can say or insert, and we can insert 1. So if we've already counted a vote for this, then we just increment it now that we see a new one. Otherwise, we'll insert 1 as the default. And then just here, should return the view data. And we're saying, okay, view data. This should have the options, the end time, and the tally. Okay. Not the options. Okay. And then you can write unit tests in one way, but actually I'm going to show you write integration tests with our new integration testing library. But before that, I think we should deploy this thing on the chain. So let's do that. Let me just get this in fun. Okay. So that's one here. So what we're going to use is to say cargo Concordium build. And then we want to say the out should be Concordium out module 1. So where do we want this module? And then we can say embed schema as well. Schema embed. Okay, so what is happening here is this schema thing is like, so I have a few typos. Yes. So when I'm calling this this thing here, we're saying that we're building the smart contract and we want the output, the WASM file, to be put here. And then we want the schema, which is like this information that is used for allowing us to use JSON parameters to be embedded into the WASM module. Okay, and so now we can see that the file is created over here, which is a WASM file that we can't make a binary file. And what we're doing then is that we are using Concordium client, and we want to say GPC IP what's it, node dot Concordium testnet.com, right? I moved them. Okay, well, you're going to use this command whenever you want to communicate with our public node. I have this shortcut, which is CLT, which does the same thing. Okay, so what we're going to do is say module deploy, and we're going to call it, so we're deploying this module, and we want to name it here, and the name is just a local thing. So here it says it uses 5,000 or 50,000 energy. That's the cost that you're paying. That is then converted to CCD, which is our currency. Oh, I find enough money. Okay, that's a bit annoying. I didn't check that. Okay, but let's just move on, thinking that it works. And then what we're going to do is to say, we will assume that I will run the commands and then it will fail, but I can show you the results. So then we say contract init, and we say voting 5, the name of the module, and then we say the parameter JSON, and then we can give the init parameter, and we say that we want to initialize the voting contract and then provide a limit on the energy. That's because the contract could loop forever, so we want to say don't use any more energy than this. So the init parameter is actually just this JSON file, and then with an int time and options and then description. So we would run this command that I just showed, cc init, and then it will show us that the contract was created with some address, and then and this all happens on testnet, where you can get free CCD if you remember to get enough, as I'm apparently right now. And then afterwards, you can say contract show, and then you can see the contract. This is one I deployed yesterday. And you can see the owner and the name of the contract and the module reference and its balance and its different functions that it has, like the parameter, like a vote here, it takes like a string. It has like a different kinds of errors that it can return. And then the last thing that we can do here is to say contract update, and then we want to say the vote. We're calling the vote here, and we're sending in a vote parameter, which is just a JSON file with DK written in it, and then we can vote. And then after that, we can actually say contract invoke, which is a command for calling a contract, but without like updating it. So you can just like get the output of it, but it won't persist anything on the state. Voting for, and then we say entry point view, and then we can see here that's the view data that we got. So we can see the return is like what we get is description, and we get the end time, and then we get the tally. So one person has voted for Denmark. That's what we get. Okay. So now we have 20 minutes left, and I will do a quick introduction to testing, and then we can have time for some questions. So what we're going to do is to say go into a TOML file, and then we're going to create a new section here. Def dependencies, which are like dependencies you only need while testing, or like while not things that shouldn't be included in the final outcome. So here we are getting this smart contract testing version 1, version new, version 1.0. And then we are creating a new folder called tests. And in here, okay, tests.rs. This is where our tests will live. And yes, we'll use the Concordium testing. And we will also use voting. So we'll use our own contract here because it has the types that we need. Then we define a test, which you do by creating a function. Test now. We don't have time for one. And then when you annotate it with a test attribute here, then what happens is that when the test runner, when you run cargo test, it will find it and run it. So what we're going to do with this integration testing is it's very similar to like a unit test for this one, but you can actually do a lot of complex things. Like you can, with this integration testing library, you can have like multiple accounts and contracts and all sorts of things only existing in the testing like framework in here, and then like have contracts in like call each other and all sort of things, and then check the output. So that's very neat. So the way that you do that is that you say you first define a chain, which is like the thing that you can it comes from this testing library, the thing but that you can create accounts on, and then we'll create an account 0, account address, which is account address. So that's just account address. And we can say chain dot account create account, and then it takes an account new. By the way, I didn't really cover that, but when you see these double colon things, that means that it's like a method on the type and not on the instance. So when it's on the instance, you say dot here, but when it's on the type, like a static method, then you just say double colon. So you want to say new, and you want to give the address here, account 0, and then you give a total balance. So here we'll make sure that it has enough for doing the things. So we say amount from the D, which is our currency, and just say plenty. And then what we're going to do is we're going to get the module. So these integration testing tests actually work directly on the WASM module that you're going to deploy. And that's really nice because it also uses the same WASM interpreter like for running the module as the actual nodes. So you get a high degree of certainty that if your tests succeed and you have good tests, then they will work in the exact same way on the blockchain. That's very nice. So get the module, module load v1, and we'll load it. Concordium out module.wasm.v1, and then this returns a result, of course, because the file could be missing or something. And so we just unwrap it here, which is like the I mean, it's not good to do in production, but it might be perfectly fine for tests. It's just saying like, you know, try to extract the OK value, and then otherwise like panic and stop the program. So here we get the WASM module, and then we can say, then we'll try to deploy it on the chain, and we say module deploy, and we say, so we have this signer, the notion of a signer, which is all it does here, like on the blockchain, you sign your transactions with your account keys, but here you don't really have these account keys, but it still affects the cost of the transaction if you sign it with multiple keys. So we just create a new signer here with one key. It's not that necessary to think about. It's just because if you want to check the exact costs or something like that, then it's useful. And then the sender, there will be the account 0, and then the module would be the module given here. And again, we unwrap. That might also fail. The module could be invalid, or you could have insufficient funds, as I just had before. Then we're going to initiate init, we're going to initialize the contract. Contract init. And again, we give the signer, we give the sender, and then we say how much energy are we supposed to use. We say 1,000 into, then it's converted into the energy, and then the payload contract, init contract payload. Oops, that's what we need to do. Let's do some formatting. It's like this. Here we go. So we're sending 0 CCD, and the module reference is we can get that from the module here. So that's like the hash of the module, and then the init name here, own contract name. You want to check, and that is, it also says that init and then underscore the contract name, and then the parameter. What is the parameter that we're giving? We're getting a parameter new from serial. We have tutorials explaining this in much more detail, but I will. So that's why it's, and also due to time, there's a limit. So here, what we're doing is that we are creating this init parameter, and it does no init parameter, even though it's in here. And that's because, again, Rust is trying to be safe by default. So all these things are private by default, except if you write pub. So let's just do that. Here we're making the things public. And again, if you just make the type public, then you can't access the fields. We want to do that. Okay. Delete this one. Public. Okay. And init parameter. And it probably has fill some struct fields. Yes. Selection. And it's converting it into a string. And then we have some options. Rust, when you see this exclamation mark, it means it's a macro, so it will generate some code for you. And here we're just generating some different loading, like a vector of different sizes. And here we are steps, and then the end time, which is time timestamp millis. And then this actually from serial that can also fail. So we'll do an unwrap here as well. There'll be a lot of unwraps in this. That's so far. Okay, that's for test string. Okay. And then we'll have the contract address here. So I don't think we have time to do an update, but this, you get the gist of it, I think. You create a chain, which is like the thing that will hold the various accounts and modules, contracts, and these sort of things. And then you can say, your test would usually be like something like, update, like you can load the module, deploy it, initialize it, and then you do an update with chain.contract update, and then you might call the, road, and then afterwards you can do check view, where you can do maybe like chain.contract invoke, and then you get then finally you would do like something insert a view dot I don't know, tally, the length of the tally is equal to 1 because there was only one vote, right? And then maybe you have 2 votes here, and then you check that, or you check that it actually voted on the right things. But that would be like a typical test here. So I think that is the end of it. And now we have 8 minutes plus whatever time people want to stay on for questions. So I'm sorry that it was a bit fast here and then, but I hope that you got the gist of it. You have to work on it yourself anyhow and read our tutorials. We cover all of this as well. And of course, we are ready for support as well.
Thank you for that, Casper. So I thank you for the guys who stuck on for the entire session. This was very helpful for people who are going to code for the Concordium layer for the first time. Is there anyone with a technical question directly aimed at Casper right now? We are at the last 7 minutes of the session, so we can utilize that time. I'm inviting participants to raise hands, or you can post your questions on the chat also. Alternatively, since we have a recording, we did manage to get a recording of the session, as I can see here. Marco and I can work on making this available for the benefit of participants who come in later as well, as a precursor to people who maybe will join tomorrow's session directly. Lokeshwaran has a question here, Casper, where to get the fee amount?
Yeah. So I will cover that tomorrow, how to get that. But basically, hold on, let me just check that. Yes, I'll just share my screen again. So you would have to use one of our wallets to create an account, and then let me just. Sorry, wrong button. I just wanted to go to a different tab too. And then, yeah, so you would download one of our wallets, and then, for example, the web wallet, that's what I recommend for this. And then in here, you go in to like you create an account, like an identity, and then an account. And then if you don't have any, I think I can create a new account, right? Add new. So let's create a new account. I will show this tomorrow as well. But then once it's finalized, then you can go into your, because this is on testnet, then you can go into your transactions. So we'll take 10 seconds or so. Then you can go in and get like a request some amount, request CCD, and you will get, I think it's 20,000 now, is it not? But at least you'll get some CCD, and then you can use that for, yeah, okay, I think it's also, yeah, 20,000. And then you have 20,000 CCD for using it. And if you run out, you can always create more accounts and then send money between them. Yeah.
Thanks, Casper. Anyone else? I'm leaving the floor open for questions because now would be a good time to get one out of the way. Other than that, a general reminder for those of you active within your own communities, registrations for the Concordia 2023 hackathon will end at midnight today. And the hackathon officially kicks off tomorrow. Post the workshop, we'll all start building together. So again, thank you, Lokeshwaran, for asking for this question. And we'll come back to this again more natively tomorrow as well. Anyone else with a question here? I think we're good. Before I, okay. ML has sent out a note. In case you mean in the smart contract, we had a payable flag for the function and for calling the. All right. Thanks, ML. First of all, yeah, thank you, Casper and ML, for being very patient hosts throughout the session. I have a quick update for the participants. We've also added some examples and use cases to the identity experiences and DeFi tracks, which is present on the Devfolio landing page. So if you go to concordia.devfolio.co to take a quick peek at the type of products that you might want to build, This is a list of suggestions from the foundation itself, and it's available there. A gentle reminder for those who will compete and potentially win one of the 3 tracks in the program, you will also become eligible for a $30,000 grant into the future expansion of your project, in addition to your cash rewards. So all the very best to those participating in Concordia. Thank you once again for helping us spread the word. Thank you for participating, and we will see you again tomorrow. So Casper, it'll be you and Emil again tomorrow, yeah? We will meet the foundation team again tomorrow. Thanks, guys. Thank you for joining in.
Yeah, see you.